So the idea of this video is to do a little introduction, or at least go through what I've been learning about this machine, which is the IS-CGB emulator, which is a development unit created by Intelligent System for Nintendo. And this unit allows you to debug and test software developed for the Game Boy Color and the Game Boy Advance. I've only tested with the Game Boy Color, so I'm not 100% sure it works with the Game Boy Advance, but at least it's marked in the background, in the back of this big machine, which you can see here in the corner. And it's this gray thing, this gray one. So as far as I know, this is the first, at least the first one that started looking like a dev kit that Intelligent Systems made, and this machine is probably like almost 20 years old, and previous to that, I think they were just using like exposed boards and exposed kits for developing, at least the ones I've seen. And this is the first one that looks very decent, with a kind of nice case, and you can at least have like a useful interface. You can know that here goes a cartridge, and you in the back you have the SCSI ports, and the SCSI the SCSI ID setup, and yeah, it's fairly easy to use. It's not overwhelming in any way, at least in the external part. This is this purple Game Boy that came with the unit. It's a special Game Boy in some way. And why is it special? Because it connects via this probe to this emulator, and allows this machine to control the emulator to control the Game Boy, and to set breakpoints, and to inspect the memory, and to poke memory. And I can imagine that what this machine does is have a copy of memory inside of itself, and that memory is exposed to the debugger via the SCSI port, the SCSI interface. This machine comes with 20, as far as I know, 24 megabytes of RAM. So it's a beast compared to the Game Boy. And this cable also provides current to the Game Boy, so it can run without batteries. Actually, you can't add batteries to this; it won't work. But you can also see these two cables, the purple and the gray one, and those are a way for this machine to connect to the CPU of the Game Boy. And here you can see how this cable kind of moves into the Game Boy. And here's a comparison with, for example, this other Game Boy, which is a retail one, and they both have this kind of input port here, and I'm pretty sure you can, just as I say, superficial way, I'm pretty sure you could turn this Game Boy into a dev unit by just adding these two cables there. But I'm not sure, maybe there's another component inside that makes it easy for doing the setting up breakpoints, and I don't know, reading memory and stuff like that. But I guess this is mostly used for I/O, at least simple I/O. And I'm pretty sure the big machine just keeps a copy of the state of the Game Boy inside of it. I don't know. So for running the software, I have to run it on an old computer I used to have, which is kind of 10. I think it's 10 years old. So no, it's older than that. But it has Windows XP. The software that came with the device is it was a bit old, and it didn't work with my machine. It came in this 3.5 inch floppy disk stuff, these ones, and the software was so old, and the drivers didn't work, and I thought I'd run into a wall, but gladly the homebrew community is nice, and there's always someone that saves this material, and someone uploaded and shared with me at least what I think is this, at least the latest software package that was provided by Intelligent Systems, and this one is from 2001. The one that I had was from 1998, so it was a bit old, and this one was perfect because it worked with Windows XP, and as immediately detected the drivers for the emulator, for the IS-CGB emulator, and that was great. It sounds like really easy, but it actually took me a while, a couple of months to be able to set up all these parts, especially since a lot of the components were old, and for example I didn't have a SCSI card, and I had to buy one from eBay, and and the software and everything. So I'm getting an old computer since I don't have old computers laying around. So the software that came with with the the tool was, I mean, the software that was provided by this user was first the SDK, and the SDK is not like, it's not how we think of SDKs currently, where there's a library, and probably there's some useful functions that allow us to interface with hardware and stuff like that. No, this is just an assembler and a linker, and that's it. The assembler and the linker are really well documented, and the API that I mean the API, the software package that this person shared with me came with an English version of the SDK, which, I mean, the documentation, because, and this is really useful because the first version I read of this was in Japanese, and it was a pain in the ass to go with Google Translate, and I actually have a physical document that came with the machine, and I had to translate it using this Google Translate application for mobile, and taking pictures and going through each paragraph, and I'm trying to understand how to set up, because it was the manual to set up this machine and how to connect it with my machine, my development station, and so yeah, this is great, and this it comes with really useful macros and some pseudo functions and stuff like that. Very useful. Very similar to RGBDS toolchain, which also comes with assembler and linker. But the cool thing about this is that the linker outputs a file with an extension ISX, and this ISX also, you can also make this ISX store a symbol table, and this symbol table is very extremely useful for debugging. So I'll show you in a minute why is it useful and how you can use it in this environment. The other tool is this IS-CGB emulator. It's just a CAD program, and this I would have loved that this program worked with this machine, because I love painting and I love pixel art and stuff like that, and this tool is perfect for artists that are working with the machine, because you can draw. It's like a paint tool, and you can draw, and so for example I'm gonna do a character here really fast. You can do a character here, and this here I'm setting the tiles, but you can draw like individual 8x8 like sections or tiles, and then you can immediately test it in the emulator. Yeah, but sadly this doesn't work on this machine. This only supports debugger and emulator. And the next tool is the emulator. The emulator is, as far as I know, looking into a very superficial way, is just a way of uploading in a fast way your tools, your applications, and run it immediately on the Game Boy. So I have this brainfuck emulator, brainfuck emulator I made a while ago, and the good thing is that this has a nice interface, and I can just drag and drop any application here and run it. And you'll see here in the screen, it showed the Game Boy logo, and I can just run my application. And this is just a brainfuck virtual machine executing a program that is written in brainfuck that is running in a Game Boy. So this is just mostly to easily and test fast any program you're making without going through the hassle of running the debugger, which is sometimes can be slower, and it generally start with a breakpoint in the first like in the entry point of your program. But this also provides a little print debug interface that it's embedded. As far as I read in the documentation, it's embedded in the same machine, in the IS-CGB emulator. Wait. So the most interesting, for at least for me, is the debugger. And this is, you can see it here, it's resetting the Game Boy. And it's probably gonna load the last program I already loaded here, but I can load any game. It's the same way you can drag and drop programs here. And I'm just gonna load, for example, a game I developed a while ago that it's called Flappy Boy. It's a Flappy Bird clone, and I developed this game with RGBDS, which is an open source toolchain, which is just an assembler and linker. And this shows that this debugger can also run ROMs, so probably can just like download any ROM and put it here and inspect it while it's running in the machine. So that it's kind of nice. But you don't get any information from symbol tables and what address is what and information like that. But we can look at it. So here is just loading a binary file. And I can reset the hardware. And I can just run it, just do a free run for it. And you can see here is showing the screen, the main screen, and then I'm going to the game and I can just jump, whatever. So look at this part here. You can see the text blinking. Well, now I'm gonna set up force a breakpoint here, and you can see it stop blinking, and now I can step into the program, go instruction by instruction. Probably this is just this looks like them loading from this, and it might be something to do with the vertical line. I was doing some effects in the I think it has to do with the blinking, because what I'm doing here is I'm going through each scan line, and when I reach here, I detect if I need to show a black font or a transparent font. And when I reach here, I look into that flag, and if it's transparent, I set the palette for the whole background to be transparent, and that's how I make the blinking stuff. Yeah, but you can see here it might be a bit confusing because it's just a huge stream of instructions that can be a bit nonsense if you don't have the source code. So here I'm gonna show this test ISX, and this is a file that was built using the official toolchain. So if I move it here, you can see I can choose to load the symbols, the source lines, the source code, and this is going to be a lot useful for testing and debugging stuff. And I reset hardware. And if I go to the source code, you can see here I can actually step in the source code. And if I go, you can see here jumping, and I'm resetting the stack and loading some data and calling some routine and whatever. And you can even see here in this disassemble, I actually have the symbols for this program. You can see here user, ROM data bytes, subroutine check, etc., etc. And this is extremely useful for developing software, at least here. And that's for the official software that this unit supports. On my spare time, I've also been doing this thing that I call the transfer upload debug server, and this allows me to develop some applications in my computer. So I can use RGBDS. With this tool, I can just connect to the server and upload it. And this server, what it does is immediately run the debugger with the file I've uploaded. So if I call to with the IP, you will see here that it immediately starts the debugger. And if I call accept, I can do a free run, and you will see here a little guy walking, which is a kind of a test game I made for a game jam. But yeah, but that is a simple tool I wanted to use. One cool thing that the software package came with, and it's the emulator API for external applications, and here it is. So this means you can actually write your own debugger with this. This is a simple, extremely simple API, just a couple of functions, and what allows you to do is connect to a device, open connection, and then just read-write bytes. And with that, you can build a debugger as this, or even as BGB, which you can visualize the screen in your own application, which I think it would be extremely cool to have. And I'm kind of interested, and I want to do something with this. Especially because I hate the fact that I have to connect to open the remote desktop connection software, and I don't like it, and I don't want to develop my stuff on this old machine, especially because this one is extremely slow and programming in it is a bit annoying, especially through the internet, and yeah, even if it's in the same network, you can get some lag at some point. Even opening this file feels extremely slow. So I hope at some point I can do something with this. I'm really interested in doing a little, at least testing how I could develop a software that sends commands to a server application that is here, and that server application runs the commands here that then I can send me through TCP to my main machine, kind of like how I'm doing the transfer upload debug server, but with a debugger, and then that way I don't have to use this thing. That would be ideal, at least for me. And that's it. I am sorry that the video is so long, and I hope it was interesting. I do plan on making a more extensed blog post which can go more into details and maybe upload the software, upload some pictures of the internal components, and I hope this was useful. Well, that's it. Thanks. Bye.